Are you recording now?
Yeah.
Subscribe to Albert.com.
All right. Guys, cut it out. Don't do that. That's not nice. Just stop. We're being silly. Stop. All right, let's look at number 19 next. This one here asks for the domain of your function shown below. There's a mapping right here. Remember the domain. If you remember the T-chart, all you have to do if you forget is think of Dora, and that way it'll remind you your domain are your x's. So these are your x's right here. They will put them in order, so -5, -2, 0, 5. So it looks like they're already in order, so you just need to look for those numbers here, which would have been G. Very simple. If they would want the range, they would want these numbers. Okay? Alright, so let's look at number 20.
Can I grab that? The X.
This one, well, there's two different ways you can do this one. It says this f of x equals 5x squared. What's 5x minus 10? What's the value of f of 5? So remember that what's in the parentheses is your x. That's why there's a variable in here that says x. So that means that's what that number represents. They're trying to let you know that. So literally you just have to substitute. Take that number and go plug it in for the two places where you see your x. So this is what you would end up with. It'd be 5 times x squared. Okay, x is 5, so 5 squared, plus 5 times 5, because that's another x right there, and then minus 10. So that part right there, you can go ahead and either work out mentally or do it in your calculator. 5 squared is 25, times 5 would be what, 125? And then plus 5 times 5 is 25, minus 10. So if you think about it, add from left to right. This is 150 minus 10, that's 140. Okay. Now that's one way you could do it. If you want to, you can do this. Go ahead and write this down too. You could graph it and do a control T. So when in doubt, graph it out, because the x would have been 5. So when in, right, just like their little rap song, when in doubt, graph it out, right? Or you gotta graph it out. Graph it out. I've been showing that video, so everybody really liked it. Alright, so 5 would have been 140 on your table. So watch, you could graph it. Actually, yeah, I've been getting really good. They're like, wow, that was really cool. They did a good job. They really liked it. Alright, so right here, if you scroll down, please look. You could just graph and control T. So notice, the x is 5, and then you just look for your answer under the y column. Okay. Alright, so let's look at 21. Number 21, I'm going to show you how you can use the store option. Alright, so let's look at number 21. On number 21, the best way to work this out would be to use your store key. Now, some of you may have tried it and it probably didn't work. The reason is every single variable in there needs to have a number for it. So if you think about it, here's the problem right here. Every variable, so your x would have to have a variable stored for it.
5, 7, 9.
Yeah, let's use 3.
X, 5, 8.
A, we can use a 5. And then we've got a B,
7.
so 7.
And 9, C.
That's going to be what, the B?
Yeah.
And then you can use 9. I think somebody was saying, though, you should use prime numbers. 9 is not prime, but we'll try it anyway. And so every single one of these variables would have to have a number stored in it. And then all you do is see what it gives you. So let's try it. Try it with me. Go ahead and go to the first app. Some of you forget how to use the store option. You need to practice. So we're going to store a 3, and then you do control variable and store it in for the x. You got to have a number in for that variable. Then we're going to use 5, control store, and put it in for a. Then we'll do, what was it, 7, control store, that's going to be for b. And then we'll try 9, control store for c. And then all you got to do is enter it. So let's do control divide. It's a fraction, and if you look at the fraction, it's x to the a times, you might want to put a times there because you have two variables side by side. So x raised to the a times, and then x raised to the b. Oops. Don't do what I'm doing. I've got that x in the power. You're going to have to move forward right here. Get out of the power right here. So then it's x raised to the b, and then on the bottom, x raised to the c.
Also, you have the multiplication number.
I forgot to multiply. Oops,
Oh, you have double that.
right there. Right there, right?
Yeah. No, because like, look, you said.
Oh, I see it. I see it. The A, right?
Yeah.
Has like a little times in it.
There you go. Now you got it.
So yeah, we're looking for the one that's going to give us the value of 27. So, which one of these gives you a value of 27? That's what we need to find out. You're picking C, let's try C.
I'm guessing.
D?
Oh, yeah.
Alright, so let's try D then. If y'all think it's D, I'm going to go ahead and try that one. X raised to the, what is it, A plus B minus C, right? And then, yeah, it is C.
I knew it.
What?
This one. This one gives us 27. That's the target number. Look at your numbers. Okay? Alright. Let's go ahead and look at the next question, number 22. What's that? You want to talk? Read the problem for us.
Dr. Cano Freshman Academy is selling tickets to a choral
Coral, yeah, right.
performance on the first day of ticket sales. The school sold 3 senior citizen tickets and 1 child ticket for the total of $38. The school took in 52 on the second day by selling 3 senior tickets and 2 child tickets. Which system of equations can be used to determine x, the number of senior tickets, and y, the number of child tickets?
So if you look, if you would want to go back, and you would definitely want to use a highlighter for this type of problem. I've told you that before, because you want to look for your totals, you want to look to see what are the prices of the tickets, you know, how many tickets did they get, all that information is important. So we can start by looking at the first day. So the first day they sold tickets, the sales, it says they sold 3 senior citizen tickets and 1 child for a total of $38. And then the school took in $52 on the second day by selling 3 senior tickets and then 2 child. So which system of equations can be used to determine x, the number of senior, that's what the x represents, and y, the number of child? So you want to go back and again look for your totals. The first total was 38. Something has to calculate to equal the $38. So if you go back and look at it, it says that they sold 3 senior and 1 child. So senior is x. You know, they told you that the x was going to represent senior, and that's important to know, and that y would represent child ticket. And so it would be 3 times x plus, and then how many child? 1, so 1 times y. That would be your first equation. second equation, because this is a system, you gotta understand, you're gonna need another equation. And they did give us another total, it's right here. They said that on the second day, they sold $52. And it was by selling 3 senior tickets and then 2 child. So plus 2Y. So one of these answers out here on the side will hopefully represent this. Any of them work?
Oh, wait.
Anyone? G, right? Yes, this one Y. They dropped the 1, and that's exactly what will happen. Like, they do simplify them, but yeah, the correct answer is G. Okay? Gotta read the question. Alright, so let's look at number 23. Number 23 says, which expression is equivalent to this? Remember that equivalent means equal to. And so the best way to do that is graph and match. This is already the third problem where we've had to find it and graph and match. Basically, that's all you have to do. Point it out, graph it out. Oh, y'all don't have that one? Maybe, they probably deleted it. Alright,